Hey ho. How's everybody doing? Good job, Kyle. Anybody got any questions or anything I can help with while we're waiting for class to start?
I really don't like Zoom.
In what way do you not like Zoom?
When you click on it, it defaults to the group chat or like the chat thingy. So when you hit space to unmute yourself, it just puts a bunch of spaces in there.
Yeah, that is very annoying. If you don't have the chat window open, it doesn't do that. But then you can't see the chat.
Right.
I want to have the chat open, so if you type something, I can see it. So then I totally can't use the space to mute thing. Which, yeah, I mean, it's probably less of an issue for me because I'm just basically talking all the time, so I don't actually mute the mic much. But for you folks to be able to like hit the space bar, come in, say something, and then release the space bar, that would be really nice, and it doesn't work very well. So, yeah,
Easiest way I can see doing it is double clicking on like the speakers, so it full screens it, and then it gets rid of the chat temporarily. You could just double click out.
Oh, that's interesting. Okay. You can also just click once on the chat icon, and the chat will disappear and come back, right?
This is true. So for
But
measuring in terms of clicking, I
yeah,
guess yours is more efficient.
I don't know. Um, so, uh, are there any other like Zoom issues people are having? Are the videos? When I post the videos, is anybody looking at those? Do those work okay? Any sort of feedback on that?
I use those sometimes if there's like something I need to double check. Like the other day I was went over the identities again
Okay.
for the homework. So I don't know. I use them.
So for that to be useful, how important is it that there be sort of a fairly detailed kind of table of contents on the videos?
I don't think it's super important. You can kind of hunt and find what you're looking for. It's nice, but
because I found that doing that was taking up way too much time.
Yeah.
And so it kind of, you may have noticed it was happening, and then it just sort of disappeared. But I could do something where, like, I don't know, if one of you went and did it, I could give you, I don't know, some extra credit or something. If it would be useful to the community, we could find a way to sort of buy somebody's energy to make it happen. But it's probably not going to happen. I'm probably not going to do it. I think that part has become clear to me.
Yeah, that's okay.
But, if the community wants to make it happen, let me know, and we can try to make that a thing. But probably ain't going to be me. So, but I'm glad that you found it useful when you needed to look something up. That was cool. Well, I'm pretty pleased at how many people are showing up at 9:15 in the morning for an online class. I think the numbers have been pretty good. So yay for you folks. Okay, so let's go ahead and start. First, apologies. There was a pile of confusing things due on Friday because I had not moved some chapter 12 stuff out of the way, and the chapter 9 assignment was still really long, and yeah, that was a bit of a mess. And I thought I dealt with it at the beginning of the week, and apparently I had gotten partway into it, then had gotten distracted by another meeting and had just never come back and finished it. So that's now all sorted out. So Friday, I've split what was the second half of chapter 9 into two more. I mean, so there's now 3 chapter 9 assignments. The one you've already turned in, one due Friday, which is only 4-ish or 5-ish assignments, and then another one due next week. That's some more translation problems, but going from logic to English. So the stuff due Friday is English to logic, and that's what we'll focus on today. And then the stuff due next week is logic to English. And then I'll push the chapter 12 stuff off into some distant wilderness that we'll deal with after the exam. So apologies for the confusion there. That was just bad management on my part. Reminder that the exam will go out on Friday. I'll try to share it out before class, maybe even Thursday night if I get it sorted out. And then we can use, we'll go over it Friday in class, and we can use as much time on Friday to talk about it as people want. And we can also use as much class time Monday and Wednesday to talk about the exam if people would find that useful. So, bring questions to class and we'll take time and talk about them. I made the exam due Thursday night, April 9th at 10 p.m. So you don't have quite a week. Like, it'll be officially handed out Friday morning. You've got until the following Thursday night to finish it. So you should plan accordingly. It would be nice to get that turned in on time as best as the universe allows. And I realize it's a complicated universe because I would really like to work on grading those over the weekend, if at all possible, so that you can get them back in time to talk to your advisors, et cetera, about grade basis change and other scheduling changes if you find that that would be useful based on that information. Hopefully it'll all be good. And hopefully I'll get everything graded over the weekend, please. But that's the plan. So are there questions about any of the bookkeeping stuff?
I have a question.
Yep, go for it.
Would it be all right if we used a whiteboard for the test?
Oh, that's an interesting, like an actual physical whiteboard and take pictures of it, or a digital whiteboard, a physical. Yeah, no, I mean, a physical whiteboard and pictures of it's not much different on my end than a piece of paper and pictures of that, right? And, I mean, with any of these things, the clearer your handwriting is, the better, he says, using the tablet with terrible handwriting, but whatever. I think grading this is going to be, frankly, a real pain because there's going to be all kinds of different things turned in. But you doing a whiteboard's not going to make that worse. I mean, it's just going to be another in a big pile of very different things. And if it works better for you and you can get a decent picture of it, I'm totally fine with that.
I went and got some of these fine point expo markers for a little whiteboard. Super nice.
Oh, yeah, right. That would be awesome. And then, pictures of that and then submit those. That would be totally cool. So, yeah, that's great. So thank you to both Kyle and Cole for the suggestions. I hadn't even thought about that. We don't have a whiteboard here. I tend to do pen and paper, But yeah, a whiteboard might be really good for a lot of people. So that could be an option, and that would be totally fine by me. So does that make sense?
Yep.
Cool. Other questions? Great question. And good suggestion, Cole. Thank you. Other bookkeeping questions? Going, gone. Okay, so the battle plan for today is to focus on English to logic stuff. Now, I had done 3 examples of that on Monday. I was going to do one more example from the book. I am happy to take questions on that. And then I was actually going to try using breakout rooms and put us in groups and give you a set of English to logic problems to work on in groups for, I don't know, 10 minutes, 5 minutes, and then come back as a sort of group and see what people came up with. So does anybody have any questions about English to logic stuff before I do the one other example and then put you in little groups and we see how that goes? So are there any questions about the English to logic stuff before I do an example? Going. Okay, then pull out the tablet and share the screen, whiteboard, share. Let's do that. Okay, so the problem I want to do is exercise 929 I, which says value f dot j is always j plus I greater than f dot I. And these kinds of problems tend to cause people trouble in my experience. And so I wanted to do one of them. So there's a bunch of different ways we could start with this. I'm going to actually focus on what does it mean to say f of j is j plus I greater than f of I part, and then we'll worry about the quantifications in a little bit. So we're saying that f of j is bigger than f of I, right? And it's bigger, not in just general, like it's bigger, but it's bigger by a specific amount, j plus I. So if we were to say, as an example, x is 2 more than y, we would write that as x is y plus 2. So x is bigger than y. How much bigger than y? It's 2 bigger than y. So if we add 2 to y, we're going to get x, right? That adding this is going to bump us up from y to x. And so, and people sometimes end up with a minus here or end up adding the 2 to the other side, which is equivalent to having a minus. So you have to be careful that you get the plussing on the correct side. But in this case, that's what this would be. And so here we would have f of j is f of I plus j plus I. I don't need those parentheses, but it helps make it clear that that this is the quantity here that I'm adding. Okay. Does this part make sense? If you get questions about this part, definitely holler now, because that would be important. Going. Okay. So now, if we buy this part, then the question is this true for some I, some j, all j, right? And there are 4 options here. We could have, oops, we could imagine having for all I, for all j, for all I exists j, exists I for all j, or exists I, exists j. So the first one is saying that something's true for all pairs of I and j. The second one is saying that for every I, there is some j that makes that true. So every person has a mother, for example. The second one saying is there is a value, an I, where something's true for all j. So there is a number I where I times j equals I, and that would be 0. 0 times j is equal to 0. So there is an I that makes that true. And then the last one is saying there is an I and a j. There's some single pair, could be more, but there's at least one pair ij that makes something true. Okay. So we've got these 4 possible ways of doing the quantification on I and j. And so the question is, which of those seems to be the right approach here and why? Anybody want to make a vote?
The first one, because we know it's always true.
The first one because of the word always here, is that what you're focusing on?
Yeah.
Yeah. So this is sort of saying all I and j make this true. Certainly it's saying that all j is true, but also we're the always is also actually in some sense catching up the I here. We're saying that for every f of j and every f of I, this relationship is going to be true. So yeah, I think that's a great answer. I think the always here is really, useful for catching that. So the always here is a nice key that we probably want for all I, j, and we don't really know anything else about I and j. There aren't any constraints. So for all ij, f of j is f of I plus j plus I. And so that would be a reasonable answer to that problem. Okay? So questions about the translating from English to logic before I put you in groups and have you chase something? Unfortunately, one thing I will say is there aren't very good fast rules here. It's not like the proofs where they're hard rules. You do the rule, everything's going to be okay. Here, it's much fuzzier. You're like, English, and I hope I got this right, and I'm not. So it's a lot more awkward than the other pieces. So questions about any of that before we try it out?
Could you go over all of the different combinations of for all and exists for these variables?
So, like in this problem, look at what it would mean if we had the other combinations of quantifiers?
Yeah.
Sure, we could do that. That would be interesting. So let's say, I'm gonna change color here. If we had for all I exists J, f of J equals f of I plus J plus I, as an example. This would say for every I, there is a J such that well, given how I've written it, so I is the dominant piece, I would actually probably say something like f of I is J plus I less than f of J. So where this one is saying this relationship between f of I and f of J is always true, here it's saying it's true somewhere, but not everywhere. So this kind of stuff is hard to envision, and it's sometimes useful to make a graph. And when we get to translating from English to logic, I find graphs to be particularly helpful. So in this example, if we look at the for all version, and we have a graph that looks something like this. So this is f, and this is x. So this is f of x. This for all says that for every I and j, j is j plus I bigger than f of I. So what does that look like? Let's let's find, oops, sorry, that should be 1. Oh, that just didn't work well. Doink, 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 boom. So this is 1, 2, 3, 4, 5. Okay, so, and this will be 0. So f of 1, and we need to pick some point to get started with. Let's assume that f of 0 is 0, just to give us a thing. Then f of 1 is going to be f of 0 plus 0 plus 1. So that's going to be 1. So f of 1 is going to be there. And in general, f of k is f of 0 plus k of 0 plus k. Oh, it was the other way around, whatever. So that's going to be k. So that tells us that all of these should just go up this way. Okay. Now, does this make sense? Like if I say f of 5 is f of 2 plus 2 plus 5, well, that doesn't, because f of 2 was 2, and this is 7, and that's 9, but we had decided f of 5 was 5, so this didn't work. Maybe because I assumed 0, and maybe so maybe there's just no function that makes this true. That's one possibility. Another one is if there is a function that makes this true, f of 0 is not 0. Maybe I needed to have chosen a different value here. I'd have to think about that for a second. But without getting too lost in the weeds here, the point is, if there is an f that makes this true, it's going to be true everywhere. There's going to be some pattern that, either it's a line or it's an exponential curve or it's something that's going to be true everywhere. It's a relationship that holds for all I and j. This thing here is different. It's saying that for every I, there is some j, where f of I is something less than f of j. So that doesn't say something about the whole curve. It says something about an individual point on the curve. And again, I don't know if there's actually a function that makes this true, this whole thing true. I haven't really thought about that. Nobody's, at least that I can remember, has ever asked the question of what happens to this if you change the quantifiers. So I don't honestly know. But if it were a problem in the book, right, this would be enough to answer the question. You could just say that and be done with it, and we'd be okay. And then similarly, if you had there exists for all, actually, okay, I'm gonna look. I think it's worth talking about this set of quantifications. I'm gonna do it in a different context because I think this is gonna get really muddy and I'm not sure it's gonna be very helpful. So let's instead make a new thing and let's rewrite our possibilities. So for all exists for all, and exists. And let's consider the statement P parent XY. And we'll say that that's true if X is a parent of Y. And I think this will be easier to think about. So if I say for all X and Y, parent XY, then I'm saying for every X and Y, X is a parent of Y. Which is pretty clearly false, right? If I pick any two random people, it's not true that X is a parent of Y. That's just not going to be true, okay? So this statement is probably false. Well, it's not probably false. It is false. If I do instead for all X, there exists Y, parent XY, what does that mean in English? Anybody?
Is that saying that for everyone they have some parent out there?
Other way around, because we're saying parent is XY is true if X is a parent of Y. So we're saying for every person, there is out there someone who is their child. Does that make sense?
Yeah, that makes sense.
Yeah, so here we're saying every person has a child, which is also false. Lots of people don't have kids. So we're saying everybody there is someone who is their child. So every person has a child. Not true, okay? Does that make sense? Questions about that? Then exists X for all Y, parent XY. What does that mean? Anybody?
Does that mean there is a parent who for every child?
Almost. Well, it depends on quite what you mean by that. So do you mean every child has a parent? Because this doesn't quite say that.
Then no, that's not what I mean.
Okay. So this says there is someone where this is true for every Y, which means there is someone is the parent of everybody. So there is a person who is everybody's parent. That's what the for all Y parent Y would be saying, is that X is everybody's parent, okay? Which is also clearly not true. So X, or well, let's say there is someone is the parent of everyone. Right? Someone exists, everyone for all. So you're kind of in the neighborhood, but it's a stronger and weirder statement than what you were suggesting, I think, which is that there is this uber parent that is everybody's parent, which is also demonstrably false. That would be a terrible job to be everybody's parent. I'm glad I do not have that position. Being a parent once was a wonderful thing. I would not want to do it to 7 billion people. And then the last thing, exists X for all Y, parent XY. Oh, that's the same. I meant to have it exist here. This would be that there is some parent-child combo out there. Someone is somebody's parent. So there is a person, there are two people, X and Y, such that X is the parent of Y. So there is a pair of people that have the parent-child relationship. Okay. Questions about these four? There's actually two more I want to do here, but questions about these four? Now, the first and the last, because we're doing exists XY and for all XY, it doesn't really matter the order of the X and the Y, but for these middle two, it does. And I did them X followed by Y, but it's worth looking at what would happen if we kept the quantifiers in the order they're in, but we changed the order of the variables. So if we had for all Y, there exists X. Oh, and I lost a bar here and a bar here and a bar here. Bad me. Parent XY. So for all Y, there is an X such that parent XY. What does that one mean?
That would be like for all Y, there is a parent X.
Yes. So where up here we had every person has a child, here we're saying every person has a parent, because the for all is in the child position and the exist is in the parent position. So we're saying all people have a parent. So everyone has a parent. So this and this are similar, but they differ in what is being said about every person. Here we're saying every person has a child because the exist is in the child position. Here we're saying every person has a parent because the exist is in the parent position. Does that make sense? Questions? Okay. And then if we take this guy here and we change the X and the Y, we have exists Y for all X, parent XY. So what is this one telling us? It's a weird one. Anybody? So we're saying there is, oh, go ahead.
Is it saying like there exists some child whose parent is everyone?
Yeah, where everyone is their parent. There is someone who has everyone as a parent. So in the same way that here we were saying someone is the parent of everyone, here someone is the child of everyone. So there is someone where everybody is their parent, which is also super weird and not very plausible in my understanding of biology. So this one we could say someone is the child of everyone. And so this would be similar to this, with the difference being the parent and the child piece here. So of these 6, the only one that's actually true is this one here. Everybody has a parent. None of the other, oh no, I guess that's not true. This one's also true. So only one. This one here, there is a parent-child combination somewhere out in the world. And I think everybody else, someone's the parent of everyone, every person has a child. Yeah, those are the only 2 of the 6 that are actually true. Everything else is false. So it clearly matters which quantifiers we use, what order they're in, and the order of the variables matters, because it clearly changes the meaning of the quantifications to change those things. Questions?
So making the difference between so the difference between for all XY and then for X for Y. So the difference is, as far as I can tell, so it's supposed to be that, like, you could think of it as for all XY you can have, or there's, all of them have to be true. Like all possible combinations have to be true,
Right.
in order to make it true. And then the 4x for y, you only need one instance of it being true to make it true.
When you say 4x, 4y, I'm not sure I understand what you mean by that. Do you mean for all x, for all y?
Oh, sorry. The for each, I meant to say.
Oh, there exists x, there exists y.
Yep, that's the one.
Okay, so you're like contrasting this one and this one.
Yes.
Okay, or like this one and this one here. Yeah, so the top one, for all x, for all y, we're saying for every possible pair, x and y, the thing must be true. And if it exists x, exists y, We're saying there just needs to be a single pair somewhere in the universe that makes that thing true.
Okay.
Is that answering the right question?
Yep. Yeah.
Okay. And so those in some ways are the easier ones often to figure out. The for alls, when you're mixing the for alls and the exists, then it can be a little fuzzier to sort of be clear about what is for alling and what is existing, what is every and what is some. And it matters the order of the quantifications, and it matters the order of the variables. So, questions? So that was perhaps a long digression in response to the question, but I think it was a good question like a zillion years ago. So thanks for asking it. Other questions about the translation stuff before we give you a task in life? Okay, so I'm going to stop sharing. And I think if I type these into the chat, I think you'll have access to them when you go to the breakout room, because I think the chat will still be there. So we'll find out if I'm lying. So make sure I get the right problems. Get the book. Oh, go away. So there are 3 problems I want the groups to think about. So I want us to do 9.29 E, F, and H. And 9.29 E is every positive integer is smaller than the absolute value of some negative integer. And you can use abs.I for the absolute value of I. Okay? Do we understand the English here? Cool. And then 9.29F is cubes of integers are never even. And the book is saying don't use even.x and odd.x, but for the purposes of what you're doing right now, feel free to use them. If you want to then translate them into the exist thing that we talked about earlier, you can do that, but I'm not going to immediately sweat that. And then 9.29H is for no integer I is f.I both greater than and less than f.I. Did I get that right? Oh, less than I. Sorry, I knew something didn't seem right there. Okay, boom. So those are the 3 things that I want you to translate. So I'm going to put you in breakout rooms. So what will happen in a second is a thing will pop up saying you've been invited to go into a breakout room. And then you hit yes to that, and it'll send you off to the breakout room. There should be 3 to 4 people in each room. You can either turn on your mics and actually talk to each other, or if you want to just use the chat window and type at each other. Not everybody has a mic, so that's, pay attention to the chat window. You also will have an ask for help link at the bottom. So if you click that, it'll pop up for me, and it'll say like, this room would like you to come visit with them. And I can come into your room and answer a question or help out. But otherwise I'll be out here in the lobby, as it were. When your group feels like you've got an answer to all 3 of them, or you're just stuck, then come back to the main room. And then once everybody's back here, then we'll see what everybody came up with. But try to do this in 5-ish, 10-ish minutes. I don't know how long it's probably going to take. But, have a meaningful conversation about it and then come back and we'll see what we end up with. Does that make sense? Does anybody have questions before I sort of hit the button and send everybody off to the wilderness? Going. To the wilderness you go. Open all rooms. So I think you've all been invited. Head off to your breakout rooms. David, Finn, Jeffrey, and Kyle. Cassie, Cole, Joshua, Natasha. Jaden, Noah, Robert, and Tim. Oh, well, that maybe is good. Alice, Blake, Jack, and Richard. Aaron, Opti, and Emma. That one's a little worrying, perhaps, but Hey, folks. So breakout room 2 still seems to be busy. Everybody from that room is still in breakout room 2. All the other rooms appear to be headed our way. Although Abdi, Aaron and Emma both seem to be still in their room. Were they like busily chatting when you abandoned them?
Kind of. I just saw your message. I'm like, oh, he wants us back, and then
That's cool.
yeah.
Okay, I'm gonna close up the rooms. Looks like everybody's coming back. We'll just force Aaron and Emma to join us. Close all rooms. So while we're grabbing the last few people, did anybody have any questions or issues that you want to talk about before we run through people's answers quick?
I kind of have a question about how these like the way that stuff gets nested, and then like doing operations outside of a nested. I don't even know how to like explain it without showing you what we did, but
Well, so you want to, is there one of the three in particular that raises this question that you want to like talk about?
we only finished the first one, so
so do you want to draw, or do you want to dictate and I will draw?
I can just dictate.
Okay, so I'm pulling up a whiteboard, make a new screen. So tell me a story.
Okay, so we came up with for all I equals Z positive, like with a plus.
So for all I in the set of positive integers.
Mm-hmm. And then bar colon exists X, and then it's an integer, negative integer.
Okay.
And then absolute value ABS of X is greater than I.
Greater than, my bad. Okay.
So the kind of the question is that we have that I inside, but if it, the way I'm thinking of it is like a programming language. So would you want to reduce this down to an integer before you do that like greater than operation? Or I just don't understand how it's nested inside like that, I guess.
Gotcha. So it is you're sort of unclear on what it means to have it exist inside of for all. Is that really the question?
Yeah, I think so.
So first, before I get to that, so this is supposed to be every positive integer is smaller than the absolute value of some negative integer. So we're saying this says every positive integer. That's cool. And this is saying some negative integer. And so we're saying every positive has some relation with some negative, And what's the relationship? The relationship is that the absolute value of the positive integer is less than the absolute value of some negative integer. So for starters, I think this is a great translation. I'm totally cool with that. Now, and before I get to Cole's question, did any other group have something different that you are like, oh, I think what we had may also work, and want to share that, or end up with getting stuck somewhere or something like that with this one? Anybody? Okay. So I'm for Cole's question, how do we think about the way these things are nested? This being on the outside says that we need to figure something out. Something needs to be true for every I in this set. So it needs to be true for 1, it needs to be true for 2, it needs to be true for 3, it needs to be true for 4, to infinity, right? And what needs to be true for each of them is that there exists an x in z minus such that the absolute value of x is greater than this particular thing. So that is, we're going to need to show that that's true. And here we would need to show that this is true. Okay. And so here we're saying there is some x that makes this true. Well, it could be like absolute value of -7 is greater than 1. And in this case, we need absolute value of some negative number is greater than 4. That could be absolute value of -22 is greater than 4. Oops, I guess I didn't need that close paren. So if you want to think about it, I don't know that this helps, but if you want to think about it, it's kind of like nested loops. If you've ever done any programming, this is a bit like a loop inside of a loop. And the outer loop is saying, we need to go over all the positive integers and figure something out. And the inner loop is saying, we need to go over all the negative integers. And in this case, look for one that works. And out here, we need it to work for all of them. And that's the difference between the for all and the exists. Is it enough to find one that works, or do we have to like show that it works for all of them? I have no idea if that helped.
I mean, that makes sense. But so what would happen if you were to move the greater than operation on the outside of the exists thing? Like, how does that break it?
Because now it would, so if I'm understanding, holler if I'm not getting it right, you're suggesting for all I, z plus, and now are you just like saying put abs x greater
No,
than,
you'd still have the exists like statement, except that part where with the greater than I would be outside that parenthesis, and then you would close the whole expression.
So, okay, I'm going to need you to dictate because I'm not following exactly what you mean.
Okay.
So, so we got to here. Now, what happens next?
Then bar colon exists x with the z, and then bar again colon, then absolute value of x, and then you'd close paren, and then
That?
Yep.
Okay, so the problem here is that this needs to be a Boolean.
Mm-hmm.
because of the exists.
Okay.
And a Boolean greater than an integer doesn't make sense, right?
All right.
Boolean greater than int, bad. And you have another problem in that if this is a Boolean, this needs to be a Boolean, and it's not.
Mm-hmm.
So the body of an exists needs to be a Boolean, and abs x is not a Boolean. So the typing all kind of blows up
Okay.
if you move the abs in there. Does that make sense?
Yeah, that makes way more sense. Yeah.
Okay. So questions about this first one? 9.2e, 9.29e? Anybody? Then quick, because we got 5 minutes left. Does some group want to share 9.29f, cubes of integers are never even? Anybody? Or would somebody prefer to share 9.29h, for no integer I is f of I both greater than and less than I? Come on, be brave. You can do it. So I don't know if this means everybody was stuck or everybody's just anxious. Anybody? Okay, so I'm not sure how to read that. And given the time, I'm just going to go ahead and throw out my answers and everybody can yell at me later. So for 9.29f, cubes of integers are never even. So cubes of integers are never even. You could read that as there does not exist a cube that is even, or that all cubes are not even. And by generalized De Morgan, the two things are the same. And I don't know that I feel strongly about the difference between them. I think I'll say for all I in Z, the cube of I is not even. So that's, I think, a reasonable way to do it. An alternative, which is the same by generalized De Morgan, would be to say that there is no I whose cube is even. So those two things are equivalent by generalized De Morgan. Okay. So that would be a reasonable answer to 9.29f. And then 9.29h is, oh, did somebody raise their hand? Is that what that little thing was telling me?
Yeah, I did. So
Go for it.
in the book, it says use only addition and multiplication. Do not use exponentiation or even .x and odd .x.
Right. And I said you could, if you wanted to.
I'm sorry.
Ignore
I'm sorry.
this. But
Completely missed that
if
part.
you wanted to clean that up, you could be like, there exists a j in the integers such that I cubed is 2 times j. Right? That would say that this is even. And then you'd still have the negation in front of it if you did this one. If you did this one, you wouldn't need the negation. Does that make sense?
Yeah, that makes sense. Sorry.
No, that's totally fine. Because I meant to say that and I forgot, so I'm glad you asked. And then 9.29h, for no integer I is f of I both greater than and less than I. So for no integer, I think there does not exist seems like a great idea. That's saying there is no integer that has whatever property we're after. And what property are we after? That f of I is greater than I and f of I is less than I. So when they say both greater than and less than I, we're saying f of I is greater than I and f of I is less than I. And that this part would just collapse to false. So you could actually prove that this is true. But that's not what the point of the exercise is. So we've run out of time. Are there questions quick about any of this? I'll have the exam ready Thursday night, Friday morning, and then we'll talk about the exam Friday. If there's time, we'll talk about going from logic to English, which is actually worse, I think, than going from English to logic, weirdly enough. And then we'll see where we go from there. So any questions? Going? Okay. Thank you all very much. And I will see everybody Friday. Friday. Oh, come on. Stop share. Actually, I want to go back.